I want to show you how to do a decision tree similar to the pediatric telemedicine one in that medical decision making study from 2015. I'm just configuring the model like the rest of them. So we set willingness to pay, society's willingness to pay for one healthy year of life for a quality adjusted life year. I set that to $50,000, so a threshold or willingness to pay of $50,000 per one quality or quality adjusted life year. I'm just labeling the costs in dollars here and the effectiveness in quality or quality adjusted life years here. Label the first part of it choose. Remember from the other ones you could just label it whatever you want to. Maybe we would call this choose technology or choose clinical policy. And there's two variables that they get into detail in that medical decision-making study. One is the number of children using telemedicine. So let's just call that variable child and set it equal to 10. So we'll say that the base case scenario, the baseline model, is we'll have 10 children using telemedicine. The other one's the effectiveness of telemedicine, and that's the probability that it avoids a transfer. Let's call that effect and set it equal to 0.5 to start. Now I'm just going in and building the decision tree here. So I just want to make it like the medical decision-making study where you're choosing between telemedicine and telephone. And then what telemedicine does is telemedicine's cost-effective because it reduces transfers. So if you choose telemedicine, there's some probability there's a transfer, some probability there's no transfer. And watch children go into the model here. So this is interesting. In that study, they use a per capita cost or a per child cost of telemedicine, where telemedicine would sort of just scale up, and it's just mostly a fixed cost of telemedicine. So you pay for the telemedicine technology, and then you pay for the maintenance cost, but then that cost is shared over the number of children who are using telemedicine. So that's why it says like that cost is per child, a unit cost per child. And remember, effectiveness, the effectiveness of telemedicine is the probability that it avoids a transfer. So if there's no transfer, the probability of that is the effectiveness of telemedicine. Remember, after a chance node, after the green circle, the probabilities have to sum to 1. So if the no transfer branch is effectiveness of telemedicine, the transfer branch has to be 1 minus the effectiveness of telemedicine. And I said if you avoid a transfer, let's just say it's $0 and 10 qualities. Remember, what telemedicine does is it really has this effectiveness through avoiding transfers and through reducing those costs associated with transfers. If you draw the supply curve from the model, you could see how it scales up from telephone to telemedicine. You can see the ICER there is about $12,500, less than the $50,000 willingness to pay threshold. The ICER of telemedicine is less than the willingness to pay. So when we roll back the tree, you can see it snips off that telephone branch, crosses it out in red, and green means go, highlights telemedicine, chooses telemedicine, scales up the tree to it. Now after you undo the rollback, we could do a sensitivity analysis. And let's look at both variables we have. So we have two variables. We have, remember the number of children in the model, that's the variable called child. And the effectiveness of telemedicine, or the probability that it avoids a transfer, that's the variable called effect. Let's let effect vary from 0 to 100%, or from probability 0 to probability 1. And let's let the number of children vary from 1 to 30. So you can see here it says effectiveness of telemedicine goes from 0 to 1. Number of children using telemedicine goes from 1 to 30. Shows those two bars. The dotted line, that's the net monetary benefit of telemedicine in the base case scenario. More interesting is the tornado diagram. So this is more like the medical decision-making article where you're doing a tornado analysis of the ICER. Which variable has a larger effect on the ICER, a larger potential effect on the ICER? Effectiveness of telemedicine, the red bar, that's the wider bar, that's on top. So effectiveness of telemedicine has the larger potential influence on the ICER. And then when you draw this bivariate sensitivity analysis here, this is just like in the study, where for part of this range of values, we choose telephone, and for part of it, we choose telemedicine. So you can see on the x-axis, number of children using telemedicine, y-axis, effectiveness of telemedicine. If only a few people use it, you would only choose telemedicine. They would only be blue. You'd only choose telemedicine if effectiveness was really high. But if a lot of children use telemedicine, if 30 children use telemedicine, it would only have to be about 20% effective to choose telemedicine. And so the blue part of the graph is where we choose telemedicine, and the red part is where we choose telephone.